Take a deep breath. Seriously, do it right now. As you're pulling that air into your lungs, I want you to stop and ask yourself something. How healthy is the air inside the building you're sitting in right this very second? We spend, like 90% of our lives indoors, and yet we almost never think about this invisible ecosystem we're constantly inhaling. We obsess over eating organic food, we filter our drinking water, but the air in our schools, our offices, our hospitals, yeah, that usually remains a totally invisible, unchecked threat.
So, welcome to today's Explainer. We're going to seamlessly synthesize the science of optimal indoor air quality. We'll be breaking down some fantastic data from the Harvard Healthy Buildings program, along with key industry standards, to hand you a definitive, highly practical playbook for, breathing a whole lot easier.
Here's a quick look at our roadmap for today. We'll cover the 2 pillars of indoor air quality, 5 steps to better ventilation, measuring air exchange rates, hitting your ventilation targets, decoding GREENGUARD certification tiers, and finally, putting it all together in the ultimate healthy building. Let's jump right into Section 1, the 2 pillars of IAQ, the foundation of health.
You can actually think of a building's health exactly like your own personal health. It boils down to 2 things: exercise and a good diet. The exercise here is active ventilation. That's the physical, mechanical process of actively pushing stagnant, dirty air out of a room and pulling fresh outdoor air in. The diet, on the other hand, is passive source control, meaning we just don't bring bad air in to begin with. We feed the building a healthy diet of safe, low-emission materials. To truly optimize a space, you absolutely need both.
Okay, let's look at that first pillar, active ventilation, to really see how this works. To wrap our heads around the exercise portion of our building, we're going to lean on an incredibly credible resource. This is the 5-step guide to checking ventilation rates, and it was specifically designed for classrooms by the Harvard T.H. Chan School of Public Health's Healthy Buildings program.
Moving on to Section 2, 5 steps to better ventilation, a 5-step guide. This checklist is just brilliant. It's chronological, it's highly practical, and it takes out all the guesswork. Step 1 is super straightforward. Just measure your room dimensions so you know your total cubic volume. But Step 2 is where it gets really hands-on. You perform audio and visual checks. The Harvard Guide highlights this awesome, simple method they call the tissue test. You literally just hold a piece of light tissue paper right up near your supply and exhaust vents. If the tissue blows away, air is being supplied. If it gets sucked up against the grill, it's exhausting. It's such a fast, easy manual check you can do before you ever touch a digital sensor. From there, you measure the actual ventilation rate, compare those results to your targets, and if you're falling short, Step 5 kicks in, considering supplemental air cleaning, like popping in some portable HEPA filters.
Which brings us to Section 3, measuring air exchange rates, getting the raw data.
What I love about this matrix is how neatly it breaks down your diagnostic toolkit into 4 distinct options, totally depending on your specific setup. Say you have unit ventilators or a central air system. You can go with a physical tool called a bolometer with a capture hood to measure the literal cubic feet per minute of airflow. Super precise. But if you don't have that heavy-duty equipment on hand, no worries. There are other options that allow you to use a standard carbon dioxide monitor to estimate that ventilation rate, regardless of what kind of HVA system is running.
Actually, let's talk about the CO2 decay method for a second, because the logic behind it is just fascinating. Let's say a room is totally empty. The Harvard Guide recommends bringing in about 10 pounds of dry ice, setting up a fan on it, and deliberately spiking the room's carbon dioxide levels all the way up to 2,000 parts per million. Once it hits that peak, you pull the dry ice out. Then you simply sit back and measure how fast that CO2 drops back down toward the outdoor background level, which is usually hovering around 400 parts per million. By timing that decay rate, you totally bypass all the complex algebraic formulas. You can visually prove exactly how fast fresh outdoor air is replacing the stale indoor air. It's brilliant.
All right, Section 4, hitting your ventilation targets, grading your performance.
The single most crucial takeaway here boils down to one number: 5. According to the experts at Harvard, 5 air changes per hour, or ACH, is the gold standard benchmark for excellent indoor ventilation. Just to put that into perspective for you, 6 is considered ideal, 4 to 5 is good, and 3 to 4 is your bare minimum. So our target? We want that air turning over completely, 5 times every single hour. That leads us to Section 5, decoding GREENGUARD certification tiers, passive source control.
Here's the catch though. Even if you have stellar ventilation, perfect exercise, you are never going to achieve optimal air quality if your building has a terrible diet. If your walls, pipes, and ducts are constantly off-gassing toxic chemicals, you've got a problem. These are volatile organic compounds, or VOCs, and they notoriously hide in standard building materials. So to stop bringing bad air in, architects and facility managers rely heavily on GREENGUARD certifications. These act as a rigorous vetting system to identify low-emission materials.
This hierarchy really puts those standards into perspective. Look at the stark contrast across the three tiers here. Standard GREENGUARD certification caps total VOC emissions at 500 micrograms per cubic meter. Not bad, right? But GREENGUARD Gold slashes that allowable limit by more than half, taking it all the way down to 220. That gold standard is absolutely crucial for sensitive environments. Think schools, daycares, and healthcare facilities. And then, at the very top of the mountain, you have the formaldehyde-free certification. It maintains that strict 220 VOC limit, but goes a step further to guarantee a microscopic formaldehyde emission factor of less than or equal to just 5 micrograms per square meter per hour.
Let's wrap this up in Section 6, the ultimate healthy building, tools for clean air. Now, you might be thinking that hitting these ultra-stringent GREENGUARD Gold and formaldehyde-free standards is some kind of impossible pipe dream. But it's not. It is highly attainable with today's construction materials. A quick look at the Johns Manville portfolio totally proves this. You've got Linacoustic RC duct liners, which are gold certified. You've got HTB26 spin glass using a formaldehyde-free binder, perfect for insulating pads. You've got Zestin PVC inserts for fittings, Microlite duct wraps, and Microlock HP jacketed pipe insulations. Every single one of these hits those top-tier, low-emitting benchmarks. So the tools to give your building a clean diet, they're already right here.
But, and this is a really important but, there is a vital caveat you've got to keep in mind if you're a facility manager or designer. Even if you use the absolute cleanest materials on the market, maintaining healthy air means you have to respect the physical limits of those materials. At high temperatures, specifically anything over 450 degrees Fahrenheit, all binders, yes, even the formaldehyde-free ones, can start to thermally degrade. And when that happens, those low chemical emissions can't be guaranteed anymore. It's just a really crucial reminder that environmental health isn't a set-it-and-forget-it thing. It's an ongoing, dynamic process.
So we've covered the mechanics and the materials, the active and the passive. We know how to push the bad air out and exactly how to stop the bad air from entering in the first place. When you combine that Harvard Healthy Buildings target of 5 air changes per hour with strict GREENGUARD Gold certified materials, you literally transform an invisible threat into an invisible shield. Which leaves me with one final question for you. Next time you take a look around the space you manage or the office you sit in every day, are you ready to apply these 2 pillars and actually build for health?